Every day we use toilet paper without really thinking about it. It's one of the most common objects in our daily lives, always present and seemingly simple. A light, soft, and discreet product that we rarely associate with advanced technology or complex industrial processes. Yet behind every single roll lies highly engineered production. Industrial lines stretching dozens of meters operate continuously, transforming natural fibers into kilometers of paper in a very short time. We need to follow its complete journey, from raw materials to the final stages of industrial production. A journey where every step helps define the characteristics we take for granted every day. The foundation of the entire production process is cellulose, a natural fiber found in plants, especially in wood. It is this fiber that makes it possible to create thin yet strong materials. Different species produce fibers with different characteristics. Some have long fibers, which provide greater mechanical strength, while others have shorter fibers that contribute to softness and sheet compactness. The combination of these two types of fibers represents one of the most important decisions in designing the final product. Some manufacturers also use recycled material. This helps reduce environmental impact, but it introduces new technical challenges. They are often blended with new fibers to maintain a balance between sustainability and quality. Before entering the actual production phase, the cellulose is cleaned and prepared to remove any impurities. Even small residues could affect the color or texture of the paper. Once this preparation is complete, the fibers are ready to be transformed in the next stage, the creation of liquid pulp. At this stage, paper does not yet exist as a sheet. It exists only as a uniform mixture, composed almost entirely of water and tiny dispersed fibers. Water plays a fundamental role because it allows the fibers to move freely and distribute evenly. Mechanical agitators keep the mixture constantly in motion, preventing the fibers from accumulating or clumping together. During this stage, specific additives may be introduced to improve certain characteristics of the paper. Some help the fibers bond together, while others influence softness or absorption capacity. Everything is measured with extreme precision, because even small variations could affect the following stages. Once the liquid pulp is prepared, the moment arrives when the paper truly begins to take shape. The mixture is transferred to a section of the machine called the head box, where it is evenly spread onto a moving metal mesh. This step marks the birth of the continuous sheet. As the pulp settles onto the mesh, water immediately begins to filter through the small openings, while the fibers remain on the surface. Gradually, the fibers move closer together and begin to interweave, creating a thin yet continuous structure. It is a fast but extremely delicate process, because the thickness of the sheet must remain uniform across the entire width of the machine. The speed of the mesh and the flow of the pulp must remain perfectly synchronized to ensure stable formation. At this stage, the sheet is still very fragile and contains a large amount of water. It has not yet acquired its final strength or softness, but its basic structure is now established. The next step will be to remove excess moisture and stabilize the material through controlled pressing and drying. After the formation of the continuous sheet, the paper finally exists as a visible material, but it is still extremely wet and fragile. To make it stable and prepare it for the next processing stages, the process enters the pressing and drying phase. The sheet is guided through a series of compression rollers that apply controlled pressure to its surface. This step is mainly used to remove part of the water trapped between the fibers. It is not simply a matter of squeezing the material. After pressing, the sheet is more compact, but still contains a significant amount of moisture. To complete the drying phase, a large heated cylinder comes into play, known as the Yankee dryer. The paper adheres to the hot surface while continuing to move along the production line. The heat accelerates the evaporation of the remaining water and stabilizes the structure of the sheet. When the dry sheet reaches the end of the Yankee cylinder, one of the most decisive moments of the entire production process takes place. This step is called creping, and it is responsible for much of the softness we associate with toilet paper. During drying, the paper slightly adheres to the surface of the hot cylinder. To remove it, a blade positioned with extreme precision is used. When the sheet meets this blade, it is not simply separated from the cylinder, it is slightly compressed and released, creating tiny wrinkles across the entire surface. These microfolds modify the structure of the material. They increase the apparent volume without adding new material and make the sheet more flexible and elastic. It is precisely this transformation that creates the sensation of softness when we touch the paper. And the speed of the machine must be controlled with great precision. Even small variations can drastically change the final result. If the creping is too aggressive, the paper can weaken. If it is too light, the sheet will feel rigid. After this step, the paper has acquired many of its main characteristics, is then wound into large industrial rolls that will serve as the base for the final stages of processing. After creping, the paper has reached a stable consistency and already possesses many of the characteristics that will define the final product. However, it does not yet exist as individual rolls. At this stage, it appears as a long, continuous sheet that must be handled and prepared for the next processing steps. The sheet is then wound into enormous industrial rolls called parent rolls or master rolls. They represent a fundamental transition point between paper production and its transformation into a ready-to-use product. The winding process must be carried out with great precision. The tension applied to the sheet is constantly controlled to prevent deformation. If the paper is wound too tightly, the inner layers may compress and lose volume. If the tension is too low, the roll could become unstable. Sensors monitor speed and alignment throughout the entire process. The goal is to create a uniform roll, with a smooth surface and no imperfections. From these parent rolls, hundreds of smaller rolls will be produced. Once winding is complete, the paper is ready to enter the converting phase, where the surface will be further processed to improve structure, volume, and tactile feel. Once the parent rolls are created, the paper enters the actual converting phase. This is where the material produced so far begins to take on the familiar appearance we recognize in toilet paper rolls. The web is wound around cardboard tubes that form the core of the roll. The diameter gradually increases until it reaches the desired size. At this point, the roll is separated and cut along its width, creating individual rolls ready for the final stages of inspection and packaging. Automatic systems control tension and alignment to prevent folds or misalignment. The paper continues to move as a continuous web. To transform it into a practical and easy-to-use product, once the individual rolls are formed, production enters the quality control phase. Even though every previous step has been precisely monitored, this final stage ensures that each product meets consistent standards before reaching the consumer. Optical sensors and high-speed cameras continuously analyze the surface of the rolls as they move along the line. Potential defects such as tears, irregular folds, or variations in the embossed pattern are checked. At the same time, measuring instruments verify the thickness and compactness of the material, ensuring that each roll has uniform characteristics. Another fundamental element concerns winding tension. The roll must be compact enough to maintain its shape, but not so tight that it becomes difficult to unwind. Automatic machines test these parameters and remove any products that fall outside the required standards. The entire system is supported by a high level of automation. After quality control, the rolls enter the final stage of the production process: packaging. Automatic machines gather groups of rolls, wrap them in protective film, and seal them with precision. Every movement is synchronized to maintain the high pace of production, while the packs are prepared for transport and organized onto pallets ready for distribution. At this point, the journey of toilet paper, which began with simple cellulose fibers, can be considered complete. From raw material preparation to transformation into liquid pulp, from the formation of the continuous sheet to pressing, from drying to the creping process that creates softness, and finally, through embossing, perforation, and cutting. Every stage has contributed to defining a product that appears simple, yet is technologically complex. Looking at a finished roll, it is difficult to imagine the level of engineering hidden behind every sheet. Giant machines, digital controls, and continuous processes work together to create a perfect balance between comfort, strength, and functionality. Toilet paper represents a perfect example of invisible technology, an everyday object we use without thinking, yet born from a sophisticated and highly optimized industrial chain. And it is precisely this combination of apparent simplicity and real complexity that makes its production so fascinating. If we look at the entire process as a whole, one fundamental aspect becomes clear. The production of toilet paper is not a sequence of isolated steps, but a continuous flow in which each phase directly influences the next. Even a minimal variation in fiber preparation can modify sheet formation, just as small changes in drying or creping can alter the final perceived softness. The next time we pick up a roll of toilet paper, we might look at it with different eyes, not just as a simple object, but as the final result of a long industrial chain, where precision, engineering, and design transform something natural into an indispensable product for modern life.